Welcome to week 7, session 2. We will continue our previous discussion about distribution and transportation network design. In session 1, there are interrelations between the number of considered network nodes and the service to be offered to the customers. There are three major cost drivers to be considered during the determination of the right network design. First, there are inventory costs. Inventory costs tend to grow if the number of network facilities is increased because each facility holds a certain quantity of inventory. Besides the fact that there is plant inventory already stocked, there might also be inventory just waiting to be forwarded. Second, the cost directly associated with the usage of the facilities have to be considered. Obviously, these costs increase if the number of facilities is increased. Third, there are the transportation costs that contribute to the overall expenditures. The figure in the current slide is the typical development of the transportation cost. Up to a certain number of maintained transshipment facilities, as is represented by the dashed dot graph, additional economies of scale can be realized by consolidation. If more transshipment facilities are incorporated into the network, then the number of transport connections exceeds a threshold value. Beyond this threshold value, it is no longer possible to completely fill a truck. The average quantity to be moved by a truck decreases since total transport demand is distributed over a higher number of transport options, so that the cost per moved ton increase further, totaling two increasing cost functions for facility cost as well as inventory cost of the convex transportation cost function leads to a convex function for the total cost. Such a function has an optimal number of facilities with minimal total cost. Incorporating this optimal number of facilities minimizes the total cost of transportation system and thus contributes to balancing cost and customer satisfaction. In terms of choosing what transportation mode is appropriate for a particular transport, the current slide shows that no single transportation mode provides the ideal solution for all types of transport. The selection of the transportation mode is based on prioritizing such criteria as speed, cost, networking, security, schedules, etc. Road transport has its own advantage of door-to-door delivery and ideal for mixed cargo, typically used for first and final leg, for picking up from a source door and delivering order to destination door. Besides its most affordable price to transport and flexibility, road transport is limited to continental transport, depends on urban congestion, and can damage the two roads if loaded over than road capacity. Rail transport is typically used for all range of ground transportation, for domestic, continental, and intercontinental transport. Recently, a new potential railroad from Far East to Europe is being developed by Chinese government. In addition, rail transport is ideal for carrying heavy goods and long distances without harming the environment due to its lower emission than air and road transports. However, rail transport needs connection to other modes of transport and have to carry large volume of goods to minimize fuel consumption to load ratio, and therefore has lower frequency of delivery and transport speed. Air transport is the most expensive transportation mode, but the fastest and most safe. The high cost is due to limits for size and weight of goods to be carried by air transport. Therefore, there should be interconnection with other modes of transportation. Sea transport is the cheapest transportation mode but has limitation in terms of longer delivery time. The mode is the cheapest because a ship can carry bulky and heavy goods in standardized sea containers. However, the routes are inflexible and therefore ship will not carry any container which is missing because it has a tight schedule to stay at berth. The figure in this slide shows different distribution network structures according to transportation network design. In the case of direct shipments, distribution is organized as a direct network with storage on the manufacturing site. Alternatively, if the production strategy is assembled to order or ATO or made to order or MTO, the products can be delivered directly to customers. For instance, this has been Dell's strategy. In the retailing business, most distribution networks are organized as multi-stage systems with intermediate warehouses, distribution centers, cross-docking centers, and hub terminals. Such complex systems are typically managed by logistic service providers. Cross-docking implements the idea of the consolidation of goods from inbound trucks to outbound trucks via an intermediate transit point, for instance, cross-docking center. The special feature of cross-docking center is that the goods do not remain in the warehouse longer than 24 hours. Next, now we will watch two videos coming from the pallet networks in Dublin. You could watch the two videos at your own time and see and also learn how cross-docking operations are managed by the company. In this slide, there is a question: how do transportation time contributes to reducing or increasing supply chain cost? From a case study taken from Forbes magazine, a case of Apple iPhone and iPad delivery can answer this question. Apple is Cathay Pacific's biggest freight customer, as it prefers to move most of its stock by air instead of boat. The benefit is being able to move stock quickly rather than cheaply, with stock moved from China to US in 15 hours instead of 30 days. The lead times difference between boat and air transport has to be financed. Apple has vast cash reserves, as we know, and is making something like 3% on them at the moment. So in order to finance the shipment, they must give up making that 3% a year on their cash. Or if we prefer, that's equal to 0.25% a month, being that 30 days period that has to be financed. In our example, one Apple product costs $300. So the financing cost of shipment by both is 300 times 0.25% equal to 0.9 US dollar. On the contrary, air transport makes Apple give up making that 3% a year on their cars, or if we prefer, equal to 0.015% per 15 hours, meaning that it's come from 15 hours divided by 24 hours times 3% times 12 months divided by 30 days. That's the reason why Apple ship everything by air, because it's cheaper to do so. The direct cost of shipping are lower, but time value of money then reserves the calculation. Now let's see the figure in our slide. The figure shows direct transportation from 4 ports, 3 in northern Germany and 1 in the Netherlands. The problem is many-to-many transportation problem, and each port has access to directly transport wood to Munich, Salzburg and Prague. We can see that total available woods from 4 sources is over the demand at the 3 destination city. Each transportation route has its own cost. The problem is how to distribute the woods among 4 sources to the 3 destination city. The simplest way is that we compose a transportation problem as shown in the current slide. The objective of the problem is to minimize total transportation cost by optimizing the shipment quantity XSR to be delivered from each supplier S to destination R at cost CSR. The constraints are total shipment quantity from all source S as part of set of supplier capital S cannot exceed the total demand of particular destination R. And similarly for the second constraint, the total shipment quantity from a particular source S to, to all destination R as part of set destination capital R cannot exceed the total available capacity of source S. Finally, the last constraint says that all shipment quantity must be equal or over than 0. Alright, that's all for today's lecture, and see you in the next session in demand forecasting.